Okay, this video goes with page 131, and this is geometries of non-expanded octets. Okay, so the first thing that I want you to do is I want you to build BEF2. So you'll need to find in your kit one with 6 holes drilled in it. It's probably going to be yellow, silver, or tan, but it should have 6 holes drilled in it. And then you're gonna hook like 2 atoms. It doesn't really matter which color. I guess you could use green, or in this case I have white. It doesn't really matter the outside atoms, but we're saying that the middle atom, this yellow one, is beryllium. Then it has 2 outside atoms. Okay, they can be different, whatever, different color. It doesn't matter which color. I just picked 2 whites. But anyway, what you're gonna do is you're gonna stick one in one hole, and if you notice your structure of BEF2 that you drew before didn't have any lone pairs on the central atom. So you need to stick the other bond exactly 180 degrees away from that, and you would get BEF2, and you would see that that's linear, okay? Because the electrons want to be as far apart from each other as possible. So that's linear. Okay? Okay, now the next one down, you can build CO2. But for the rest of the models that we're building, you're going to want to use the longer sticks in your kit instead of the shorter ones, because some of them are going to need to bend. So there's shorter ones and long, thinner ones. So build it out of long, thin ones, okay? So the first thing you're going to do is you're going to get a carbon. So you can choose a black for that. And so I chose a black. And then you need to find 2 oxygens. They can be red. And so what you'll do is you'll stick 2 reds onto your black, but you're going to need a couple additional sticks. And so those are going to make your double bonds. So you can bend it over, and so you'll end up getting something like this right here. And so you'll see a carbon in the middle with 2 double bonds. Okay, that's supposed to represent CO2. And you will notice that these electrons here are as far from these as possible. So that, again, that structure is linear. Okay, now we can just keep this together to build or to go through the rest of these. Now O3, just imagine that if you had all 3 the same atoms. Okay, now these red ones won't work for this model. So, but like if you had 3, you could hook 3 blacks in a row or whatever. But you can consider that O3. But O3 has 1 double bond, 1 single bond, so you can unhook one of your bonds, 1 single bond, and then 1 lone pair. And you can see that that geometry is bent. Okay, that's bent. All right, and the bond angle would be 120 degrees. All right, now H2O, here's H2O has 2 lone pairs, so you can unhook it. So it has 2 single bonds and it has 2 lone pairs. And you can see that that's still a bent molecule, but the bond angle has changed to 109.5, or roughly that. Okay? And so then there's SO2. SO2 does have a double bond. Again, that's just going to be just like O3 basically. Okay, so you can still see it's a bent molecule with 1 lone pair. Okay, now the thing is with these 3 atom molecules. So if you have a 3 atom molecule but no lone pairs on the middle, that's linear, like this BEF2, or like CO2. When there's no lone pairs on the middle atom, 3 atoms is going to be linear, as long as it's not an expanded octet thing. Anyway, no lone pairs in the middle, linear. All right, now if you have 1 lone pair on the middle, but it's still a 3 atom molecule, that's bent. Even if you have 2 lone pairs, I know sometimes on paper that might look linear, but it's not. 2 lone pairs is bent. Okay, let's go to the next one and build a 4 atom molecule like BF3. So I'm just going to hook another, I'm going to say B is this black one, and I'm going to put another molecule on here. Now, with these kits that we have, it's about impossible to build them the right way because the holes aren't drilled properly. But if you build BF3, it would look like this, except you have to imagine it being flat, So you can put it on the table and hold it flat, okay, because there's 3 domains. They want to be as far apart from each other as possible, and it's impossible to build it for it to lay that way in this kit, but that would end up being trigonal planar. So whenever you have a 4-atom molecule with no lone pairs on the middle one, that's trigonal planar. But if you add a another bond, like let's say you make NO3, the next one down. So if you make NO3, there is a double bond, but it still kind of lies flat. Okay, so it's still trigonal planar. Okay, so it's still lying flat. It's trigonal planar. All right, now if you build NH3, so it's still a 4-atom molecule, except the difference is you have this lone pair sticking out, and basically that pushes them, the other ones, down a little bit. And what that does is that makes it trigonal pyramidal. So what I'd like you to do is kind of switch back and forth between NO3, -1, and NH3 to see the difference between trigonal pyramidal, like this one. Okay, there's a lone pair versus no lone pair. Planar. Planar, no lone, 4 atoms, no lone pair in the middle. Trigonal pyramidal, there's 4 atoms, but there's a lone pair on the middle. Okay, so planar, no lone pair. Pyramidal has a lone pair on the middle. That's how you tell the difference. Okay, turn the page, go to page 132, and basically you can just add another atom to the 4th thing. So now you have a 5-atom molecule with a non-expanded octet. And so when you have a 5-atom molecule, non-expanded octet, that shape is called tetrahedral. Basically, you have a central atom surrounded by 4 things. That's tetrahedral. Okay, so this video just went over the basic shapes that you need to know for the non-expanded octets. That's it.